Hi everyone! In this video, we will simplify a complex rational expression by using the lowest common denominator. Simplify this complex fraction. A complex rational expression has multiple fractions inside the fraction, and that gets kind of confusing. So we have a tool to make it a little nicer, which is to use the lowest common denominator to make it less complex. The lowest common denominator here, we're going to look at all of the denominators. We have a 1 under the 2, an x squared under the 18, nothing under the 1, so we can put it over a 1. 6 is over an x, and 9 is over x squared. So the lowest common denominator between 1, x, and x squared will be x squared. Now we're going to take this and multiply it to every single term in our complex rational expression. So it's like doing the distributive property by multiplying x squared on the numerator and on the denominator. And so we just need to multiply it to every single term. And so I like to write it right next to it, x squared, x squared, x squared times x squared times x squared. Just from the get-go, it just helps simplify it a little easier, faster. So on the first one, nothing cancels out, so we're just left with 2 times x squared, which is 2x squared. But on the next one, 18 over x squared times x squared, the x squareds will cancel, leaving us with just 18. And now we no longer have that fraction. And so that's the benefit of this nice tool that we have. On the denominator, 1 times x squared just gives us x squared. And then on the next one, we have x and an x squared on top, so one of the x's will cancel, leaving us with plus 6 and one of the x's. And then on the last one, x squared divided by x squared cancels, leaving us with just plus 9. Now, we don't have a complex rational expression anymore. It's just a regular rational expression. So what we're going to do is factor the numerator and denominator to see if there's anything else that we can simplify. The numerator, let's come over here and we'll factor the numerator right here. We have a common factor here between the 2 and the 18. So let's factor out the greatest common factor of 2, which leaves us with x squared minus 9. And that follows the pattern of a difference of squares. So we square root the first, giving us x, and square root the second, giving us 3, and one is positive and one is negative. And don't forget, we still have our 2. So the numerator factors into 2 times x plus 3 times x minus 3. Now let's go ahead and factor the denominator, which is x squared plus 6x plus 9. Here I see that I have another perfect square here and here, and the square root of 9 is 3. So if I take x plus 3 and square it, this means that I have a perfect square, and I can verify that by multiplying the first and the second together. 3 times x is 3x, and then doubling this gives us 6x, and this matches the middle term. If this wasn't intuitive for you, you can go ahead and factor it out like usual, and we would get x plus 3 times x plus 3. So let's go ahead and we'll write it out in the expanded form of x plus 3 times x plus 3. And now we can see that we can simplify this expression further by x plus 3 divided by x plus 3, canceling out, leaving us with 2 times x minus 3 over x plus 3. And now we're all done. We've simplified this complex rational expression into something much easier.